So we're going to start out section 7.5 with a little bit of humor. It's not exactly the one I would have written for this, but it's pretty close. So it's a math phobe's nightmare about getting into heaven. Ha ha ha. You can pause the video and check it out. But section 7.5 brings this to mind because it might be a fraction phobe's nightmare, because we're going to be working with something called complex fractions. And they're not too bad once you understand how to deal with them. But complex fractions are fractions that have fractions within fractions. So you got fractions in the numerator, fractions in the denominator. And that's true for all the problems in this section. Now, how are we going to handle this? Well, there's two ways. The first way is what I call method 1. And it's for when you have something like this, where you have one fraction divided by another fraction. Plain and simple. You don't have anything else going on. You're not adding or subtracting terms in the denominator or in the numerator. It's just a fraction divided by a fraction. So that'll be method 1. Problems 9 through 20 in your book follow along for method 1 very nicely. The trick we're going to use here really isn't anything new. If you have something in the numerator, this fraction divided by this fraction in the denominator, another way I could write that is a over b divided by c over d. And we know what to do with that. You invert and multiply by the second fraction. So it's going to be a over b times d over c. And that's going to be method 1. So let's start out with problem number 10. 10 is a nice example of this. 3 over 5 divided by 2 over 7. Invert and multiply it. 3/5 times 7/2 gives me 21 over 10. Now this is in lowest terms. If there's any cancellation that you could have done here, feel free to do it. This is in lowest terms. If you want to write it as 1 and, actually not 1, how about 2 and 1/10, then that's fine too. But the big thing here is to invert and multiply by the denominator fraction. Let me do one more like that. That would be problem number 20. So problem 20 states I've got negative 5x squared over 24 divided by x to the 5th over 56. Now maybe you want to try and race ahead of me. Try and invert and multiply like we did in problem number 10. Pause the video if you'd like. That'd be negative 5x squared over 24 times 56 over x to the 5th. As far as cleaning this up is concerned, let's see. I think there's some things that evenly divide both of these. 8 goes into 24 3 times and into 56 7 times. We share some x's. 2 of them cancel out here, leaving me with an x cubed here. And the 5 is still there, so let's multiply that all out. Negative 5 times 7 is negative 35 over 3x cubed. And that's it. Can't go any farther than that. There's no more common denominators or common factors between the numerator and the denominator. So we're good on that one. Okay. So that's method 1. There is one other problem in this book, actually 2, that follow along from method 1. That'd be 51 and 52. So if you wanted to check out those, you could do one more like that. In fact, let's do 52 real quick. 52 looks like this. 18n squared divided by 6n over 13. So a little trick with this one, because we have something in the numerator and a fraction in the denominator, let's make this a fraction. How could I make that a fraction? You got the answer? 18n squared over 1 divided by 6n over 13. And then from here, the rest is the same as it was before. Invert and multiply. So 13 over 6n. 6 goes into 6 once, n into 18 three times, and one of the n's is going to cancel, so just cancel that out. What's left? Not much. 3 times n times 13, so 39n. Technically it's 39n over 1. I'd be happiest just to see 39n. Great. Method 1 is pretty simple, but it doesn't work for everything. Method 2 will work for everything, but I suggest that if and when you can, use method 1 here. But, if push comes to shove, then method 2 will work for everything. So what's method 2? Well, method 2 is going to apply to things like problem number 22. Did you see the difference in the type of problems that we solved with method 1 and the problems we're going to solve with method 2? Here it's just one fraction in the numerator and one fraction in the denominator. Here I've got multiple fractions, so you're adding or subtracting things in the numerator and denominator. So how do you handle something like this? First, a little vocabulary. That big fraction bar constitutes what's called your primary fraction. These little guys are secondary fractions. Now, I'm not going to quiz you on this kind of vocabulary. I'm just going to use it in describing how we're going to work on these things. So let's copy problem number 22 onto the notes here. Problem 22, we'll squeeze that in here. 2/3 minus 5/2 divided by 2/3 minus 3/2. So cryptically this says multiply each secondary fraction by the LCD of all the secondary fractions. So what on earth does that mean? Well, here are all your secondary fractions. I've underlined them. And we need to multiply each of these by the LCD of each of these. So 3 and 2, well, that's our denominators here. What's the LCD of something with a 3 and a 2? Did you say 6? Then give yourself a pat on the back. 6 is the LCD for these secondary fractions. Now, how does that help us out? Well, we're going to multiply everything by 6/6. So we're going to take this whole thing and multiply by 6 in the numerator and 6 in the denominator. Now, instead of canceling the 6 and the 6, I'm going to distribute that 6 to both of these terms here, and distribute that 6 to both of these terms here. Effectively, I'm going to get 6 times this, 6 times this, 6 times this, and 6 times this. We're going to multiply the LCD times each of these secondary fractions. 6 times 2/3 minus 6 times 5/2 over 6 times 2/3 again minus 6 times 3/2. So if you just want to jump right here, the shortcut is to find the LCD and multiply each of these denominators by the LCD. I often suggest that you write that as something over 1. Now, why am I multiplying everything by the LCD? Think about that. Why am I multiplying everything by the LCD? What do I hope to accomplish? Well, I want to clean up my fraction. And you're going to clean it up by doing the cancellation here. 3 goes into 3 once and into 6 twice. 2 goes into 2 once and into 6 3 times. What am I left with in the numerator? 2 times 2 is 4, minus 3 times 5 is 15. Play that same game again in the denominator. In fact, you try and do it. try and figure out what's going on down there. Three canceled into 3 once, and into 6 twice. So again, I get a 4. This time, it's going to be 4 minus 9. In the numerator, I get negative 11. In the denominator, I get negative 5. The negatives cancel each other out. And 11/5 is in lowest terms, so that's fine as a lowest, fine as a final answer. If you wanted to write 2 1/5, that would work as well. Either one of these. But the whole point here is to get you used to simplifying a different type of fraction. Complex fractions, where we're going to use method 2. Let's try a few more to round out the section. We'll move up to problem number 42. D plus 2 over 2 divided by D over 3 minus D over 4. So a little bit different than our last one. Again, you want to look at all the denominators of our secondary fractions. So this is one whole fraction. Here's another whole fraction. Here's another whole fraction. Let's see if we can't figure out the LCD for 2, 3, and 4. The LCD here is 12. If you said 24, it would work out okay, but you're going to end up doing more simplification when it's all said and done. Let me rewrite this. D plus 2 over 2. D over 3 minus D over 4. If my LCD for all these secondary fractions is 12, I want to multiply each of those things by 12 over 1. So let's put a little parenthesis around each fraction and multiply by 12 over 1, 12 over 1, and 12 over 1. This is the shortcut that we figured out from the first problem in this section. The first problem with method 2 anyways. Now what should I do here? Hopefully you said, all right, let's cancel out the 2's. Right? You want to cancel out all these denominators. That's the whole point of multiplying by the LCD here. So 2 cancels into 12 6 times, and here once. So basically there's no denominator left that we need to worry about. A 1 here and a 4 here. A 1 here and a 3 here. So a lot of cancellation. Let's see what's left. It's going to be 6 times D plus 2, that's in the numerator, over 4D minus 3D. And we're almost there. Let's simplify a little bit in the numerator and in the denominator. In the numerator, we can distribute. So we get 6D plus 12. In the denominator, 4D minus 3D is just D. And that's fine. Leave it like this. You can't go any farther. In particular, you cannot cancel the D into this D over here because these terms in the numerator are stuck together. They're joined in mathematical matrimony. Don't break up that marriage. Okay, so problem number 70. So another one just like this one. 2 over x cubed minus 2 over x divided by 4 over x plus 8 over x squared. Okay, so let's take a careful look at all the denominators. They're all powers of x, so they're all factored. The highest power of this factor is a cube. So we're going to multiply everything through by the LCD, which is going to be x cubed. So let me rewrite this. That's going to be 2 over x cubed minus 2 over x divided by 4 over x plus 8 over x squared. This is going to get multiplied by x cubed over 1 times x cubed over 1, x cubed over 1, and x cubed over 1. Notice that all of these terms are getting multiplied by that LCD. So the x cubed term here cancels out completely. That's great. So that's going to leave behind a 2. Some more cancellation with this term. This cancels, and it's going to leave behind an x squared. So 2 minus 2x squared. In the denominator, x cancels completely. I'm left with an x squared. So x squared times 4, 4x squared, plus a little bit more here. This cancels, and it leaves behind just one x. 3 minus 2 gives me an x, so I'm left with an 8x. Now, it'd be tempting to say, hey, great, we're all done. But there is actually a little bit more that we need to do, and that is we need to factor out the 2 here. So if I factor out a 2, that leaves behind 1 minus x squared. If I factor out a 4 and an x, I'm left with x plus 2. Finally, the 2 and the 4 can cancel. I'm going to be left with 1 minus x squared over x times x plus 2. Now I'm going to give you some homework now, but I'm also going to try and come back and give you a few more problems in practice. But to get you started, try 9 through 43, 41 through 51, and 57 through 67. Good luck.